Hello students, welcome to the lecture on Database Management System, and after this lecture we will be able to learn the following objectives. Understand concept of database management system, discuss about manual database versus computerized database, explain architecture of database system, understand DBMS features and capabilities, and explain data mining, data warehousing and data marts. Let us discuss about what a database actually means. Database is a word used to describe a collection of information that is organized in a way that it is made easy to access. Database management systems. A DBMS is an aggregate of data, hardware, software and users that help an enterprise manage its operational data. The main function of a DBMS is to provide efficient and reliable methods of data retrieval to many users. Database system hardware. Computer memory can be categorized into internal memory (ROM) and external memory, magnetic disks and tapes. ROM is volatile memory, whereas external memory is non-volatile. In examining the memory needs of a DBMS, we need to consider the following issues. Data of a DBMS must have a persistent character. A DBMS must access data at a relatively high rate. Such a large quantity of data needs to be stored that the storage medium must be low cost. Database system software. Users interact with database systems through query languages which mainly have two tasks: to define the data structures that serve as receptacles for the data of the database and to allow the speedy retrieval and modification of data. There are two components of query language: data definition component, data manipulation component. A central task of DBMSs is transaction management. A transaction is a sequence of database operations that usually consist of updates with possible retrievals that must be executed in its entirety or not at all. A transaction transforms one consistent database state into another consistent database state, a property of transactions known as consistency. The transaction management component ensures that the execution of one transaction is not influenced by the execution of any other transaction. This is the isolation property of transactions. The effect of a transaction to the state of the database must be durable, that is, it must persist in the database after the execution of the transaction is completed. This is the durability property of transactions. These are the asset properties of a transaction. Users of a database system. The community of users of a DBMS classified based on their roles and interests in accessing and managing the databases. Database administrator. Once a database is created, it is his job to make decisions about the nature of data to be stored in the database, the access policies to be enforced, monitoring and tuning the performance of the database, etc. End users. These users have limited access rights and they need to have only minimal technical knowledge of the database. Application programmers. Their role is to work within existing DBMS systems and to create various reports based on the data contained in the database. Manual database versus computerized database. Manual database. Manual database is that in which data is recorded in register. With manual database, it becomes very difficult to find any records. Examples of manual database: a dictionary, a telephone directory, an encyclopedia, a catalog. a library index card, an atlas, a diary. Disadvantages of manual database. Searchability. Looking for information in a manual database may have to spend hours searching for a particular piece of data, searching individually through files and cabinets looking for the information. Analysis. With a manual database, however, a worker would have to know ahead of time what data he needed and would have to find and compile it by hand, potentially taking a substantially longer time. Data integrity. Data in manual systems is typically accessible by more than one person at a time and is vulnerable to being lost or misplaced. Damage. Manual databases are vulnerable to damage, destruction, and theft in ways that digital databases are not. Computerized database. A computer database is a set of tables that contain important information that is connected together by certain important fields of data. Examples of computerized database: Microsoft Access, SQL Server, Oracle. Advantages of a computerized database over a manual database: superior data storage capacity, faster data retrieval, data analysis is much quicker, sorting data by specific parameters is quicker, amending data is much easier, no need for correction, fluid, or the rewriting of record cards. If properly configured, there is less chance of data loss, leading to an end to misfiled cards. Easier to manage security. Computerized databases can easily employ a variety of access privileges for different users. Data redundancy. It's easy to keep more than one copy of the data in case of disaster. Advantages of manual database. We should, however, bear in mind that manual databases have their advantages too. They require no electricity. They would not suffer catastrophic failure. We might lose a few records, but the rest of the system will still work. They do not require specialist technical support to set up and maintain. They are generally easier to learn how to use and are normally simply sorted alphabetically. Assuming our storage site is secure, then we know that our data is also secure because there is no way for that data to be accessed externally. Sometimes hard copies need to be maintained for one reason or another, perhaps because there are diagrams or drawings involved. Architecture of database systems. The architecture of a DBMS can be examined from several angles. The functional architecture that identifies the main components of a DBMS. The application architecture that focuses on application uses of DBMSs. And the logical architecture that describes various levels of data abstractions. A DBMS contains several main components. The memory manager. It obtains data from the database that satisfies queries compiled by the query processor and manages the structures that contain data according to the DDL directives. The query processor. It converts a user query into instructions the DBMS can process efficiently, taking into account the current structure of the database. The transaction manager. It ensures that the execution of possibly many transactions on the DBMS satisfies the ACID properties. The standard application architecture of DBMSs is based on a client-server model. The client generates a query that is conveyed to the server. The server processes the query and returns an answer to the client. This architecture is known as two-tier architecture. In multi-tier architecture, data are scattered among various data sources that could be DBMSs, lay systems, etc. DBMS features and capabilities. DBMS building blocks. A DBMS includes four main parts. Modeling language, to define the schema of each database hosted in the DBMS according to the DBMS database model. Data structure, optimized to deal with very large amounts of data stored on a permanent data storage device. Database query language, allows users to interactively interrogate the database, analyze its data and update it according to the user's privileges on data. Transaction mechanisms, ideally guarantees asset properties in order to ensure data integrity despite concurrent user accesses and faults. DBMS features, queryability. It allows users to interactively interrogate the database, analyze its data, and update it according to the user's privileges on data. Backup and replication. Copies of attributes need to be made regularly in case primary disks or other equipment fails. Rule enforcement. Often, one wants to apply rules to attributes so that the attributes are clean and reliable. Security. Often it is desirable to limit who can see or change which attributes or groups of attributes. Computation. There are common computations requested on attributes such as counting, summing, averaging, sorting, grouping, cross-referencing, etc. Change and access logging. Often one wants to know who accessed what attributes, what was changed, and when it was changed. Logging services allow this by keeping a record of access occurrences and changes. Automated optimization. If there are frequently occurring usage patterns or requests, some DBMS can adjust themselves to improve the speed of those interactions. Metadata repository. Metadata is data describing data or data about data. Rules of DBMS. Rule 0. The system must qualify as relational, as a database, and as a management system. Rule 1. The information rule. All information in the database is to be represented in one and only one way, namely by values in column positions within rows of tables. Rule 2. The guaranteed access rule. All data must be accessible. Rule 3. The guaranteed access rule. All data must be accessible. Rule 4. Active online catalog based on the relational model. The system must support an online, inline relational catalog that is accessible to authorized users by means of their regular query language. Rule 5. The comprehensive data sub-language rule. The system must support at least one relational language that has a linear syntax, can be used both interactively and within application programs, supports data definition operations, data manipulation operations, security and integrity constraints, and transaction management operations. Rule 6. The view updating rule. All views that are theoretically editable must be editable by the system. Rule 7. High-level insert, update and delete. The system must support set at a time insert, update and delete operators. Rule 8. Physical data independence. Changes to the physical level, how the data is stored, whether in arrays or linked lists, etc., must not require a change to an application based on the structure. Rule 9. Logical data independence. Changes to the logical level, tables, columns, rows, and so on, must not require a change to an application based on the structure. Rule 10. Integrity independence. Integrity constraints must be specified separately from application programs and stored in the catalog. Rule 11. Distribution independence. The distribution of portions of the database to various locations should be invisible to users of the database. Rule 12. The non-subversion rule. If the system provides a low-level record at a time interface, then that interface cannot be used to subvert the system. Advantages of database systems. Improved data sharing. The DBMS helps create an environment in which end users have better access to more and better managed data. Improved data security. The more users access the data, the greater the risks of data security breaches. Better data integration. Wider access to well-managed data promotes an integrated view of the organization's operations and a clearer view of the big picture. Minimized data inconsistency. Data inconsistency exists when different versions of the same data appear in different places. Improved data access. The DBMS makes it possible to produce quick answers to ad hoc queries. Improved decision making. Better managed data and improved data access make it possible to generate better quality information on which better decisions are based. Increased end user productivity. The availability of data combined with the tools that transform data into usable information empowers end users to make quick, informed decisions that can make the difference between success and failure in the global economy. Disadvantages of database systems. Increased costs. The cost of maintaining the hardware, software, and personnel required to operate and manage a database system can be substantial. Management complexity. Database systems hold crucial company data that are accessed from multiple sources. Security issues must be assessed constantly. Maintaining currency. To maximize the efficiency of the database system, we must keep our system current. As a consequence, vendors are less likely to offer pricing point advantages to existing customers, and those customers might be limited in their choice of database system components. Frequent upgrade replacement cycles. Not only do the upgrades themselves cost money, but it also costs money to train database users and administrators to properly use and manage the new features. Types of databases. DBMSs come in many shapes and sizes. There are 4 structural types of database management systems. Hierarchical. It is one of the oldest methods of organizing and storing data, and it is still used by some organizations for making travel reservations. A hierarchical database is organized in pyramid fashion, like the branches of a tree extending downwards. Related fields or records are grouped together so that there are higher level records and lower level records, just like the parents in a family tree sit above the subordinated children. Network. Network databases are similar to hierarchical databases by also having a hierarchical structure. There are a few key differences, however. Instead of looking like an upside-down tree, a network database looks more like a cobweb or interconnected network of records. In network databases, children are called members and parents are called owners. The most important difference is that each child or member can have more than one parent or owner. Relational. In relational databases, the relationship between data files is relational, not hierarchical. Relational databases connect data in different files by using common data elements or a key field. Data in relational databases is stored in different tables, each having a key field that uniquely identifies each row. In thin tables or files filled with data are called relations. Tuples designates a row or record, and columns are referred to as attributes or fields. Object-oriented. Able to handle many new data types including graphics, photographs, audio and video, object-oriented databases represent a significant advance over their other database cousins. They use small, reusable chunks of software called objects. An object-oriented database can be used to store data from a variety of media sources such as photographs and text and produce work as output in a multimedia format. The objects themselves are stored in the object-oriented database. Each object consists of two elements: a piece of data, example, sound, video, text or graphics, and the instructions or software programs called methods for what to do with the data. Object-oriented databases have two disadvantages. First, they are more costly to develop. Second, most organizations are reluctant to abandon or convert from those databases that they have already invested money in developing and implementing. Data mining, data warehousing, and data marts. Data mining, also known as knowledge discovery, refers to computer-assisted tools and techniques for sifting through and analyzing these vast data stores in order to find trends, patterns, and correlations that can guide decision-making and increase understanding. The purpose of DM is to analyze and understand past trends and predict future trends. The concept of data mining is simple yet powerful. Need for data warehousing and data marts. The minute that data becomes outdated, they are deleted from the database. Fortunately, many organizations have realized the value of being able to analyze historical data in order to discover patterns of behavior and predict future trends. One of the keys to understanding the value of databases is to understand how one database, whether it is current or historical, can be related to another. Data warehousing and data marts. A data warehouse is a collection of data, usually current and historical, from multiple databases that the organization can use for analysis and decision making. The purpose, of course, is to bring key sets of data about or used by the organization into one place. Data marts are related sets of data that are grouped together and separated out from the main body of data in the data warehouse. Data marts are designed to be made available to specific sets of users. Summary. Now in the end, let us summarize what we have learnt in this lecture. The main function of a DBMS is to provide efficient and reliable methods of data retrieval to many users. Users interact with database systems through query languages. Database is a word used to describe a collection of information that is organized in a way that it is made easy to access. A database transaction mechanism ideally guarantees asset properties in order to ensure data integrity despite concurrent user accesses, concurrency control, and false fault tolerance. A data warehouse is a collection of data, usually current and historical, from multiple databases that the organization can use for analysis and decision making.